Hi, my name is Loris Crow, and we are executing a Showtime. Zig Showtime is the show where members of the Zig community come on stream to share coded ideas with the broader public. Every episode features two speakers who will present and the questions from you, the viewers. Zig Showtime is not just what you're seeing on the live stream, but also the discussions that you can have while watching. And that's why I encourage you to join one of the existing Zig communities that you can find by going to zigline.org. So, hello everyone. Episode number 12. Wow, that's nice. We are doing well, I think. The show is going forward. We don't have hiccups. We have viewership on YouTube, also on Twitch. I mean, no crazy numbers for now, but good enough. And more importantly, I think all the talks that come from our speakers are, I think, up until today, every single one has been very interesting. So before we move into the first talk, let me give you some news. So I would start by showing you. I want to start by showing you Well, let's start with something interesting in the news for real, like actual news, actual as in journalism. We have been covered by LWN. So the article is online right now. It's paywalled, so you need to be a subscriber to be able to read it. But they are gonna remove this restriction, I think, in about 5 days. And if you want to read it before then, feel free to ping me, and I'll be able to share with you what they call a subscriber link, basically a link that allows subscribers to give to other people access to articles. So I read it. This is nice article, very positive. Covers well the latest news from our blog post about LLVM, and then after that, it tries to give an idea to the readers of why Zig is a thing. So covers some of the features, and then of course compares Zig to Rust, because nowadays whatever you do, you have to be compared to Rust, right? And there's also a bunch of comments underneath. So that was interesting. This is actual news. After that, second thing that I want to show is a piece of art that was submitted to the call for art a while ago. And sorry, I kind of forgot to go and check the spreadsheet. I was sure I had enabled email notifications, but I didn't. And so this piece of art stayed there for a few weeks, months. But anyway, there you go. Yeah, I think it's a nice piece. Joachim, don't worry, I'll share it with you also later, since he's here, but he can't see. Okay, so well, I think it's a nice piece of art. Anyway, I think it's time for us to move to the first talk. Let's get to business. So, Joachim is from Germany, but he lived for most of his youth in Singapore, until when he decided to trade Kaya Toast and Singlish for German and Schäufele, and moved to Germany to study computer science. In his university, he learned how to write code for ARM and was able to actually make use of that knowledge right on time for the new Macs to come out. So the talk is implementing a ARM backend for stage 2. Joachim, the stream is yours.
Hello, everyone, and welcome to an ARM backend for the Stage 2 Zig compiler. As Loris already introduced me, I'm Joachim Schmidt, and I have some more. If you can't pronounce my name, if you have trouble, then you can just call me Joe. That shouldn't be a problem. I study at the moment in the Technische Universität Darmstadt. Like 3 semesters ago, I had a course which was about ARM assembly programming, and I decided to use that knowledge in practice and write an ARM backend for the Zig compiler. So first, an overview of some main things I'll be talking about today. First, I'll explain what compiler backends and what stage 2 and that stuff actually means, what that actually is. And then I'll go on to describe the ARM architecture, like only a little bit. Only some major details of it. Just for clarification, I'll be discussing the ARM 32-bit, like the RA 32-bit instruction set, like not the 64-bit, which is similar but also has some major differences. And then finally, I'll do a live demo on a Raspberry Pi, which I have here. I don't know if you can see it. Yeah. I hope it doesn't. The SSH still works when I'm doing that. And then I'll do a Q&A, as with every other talk. So what is a compiler actually? A compiler is just a program that converts one description of behavior into another description of behavior. And that process is called compiling. So let's look at a basic Hello World example. We have some C code, and we use GCC to compile that to an executable. Note here that you can also use LLVM, but A, I can draw a dragon, and B, I didn't have enough RAM for that, so I have to look into that. Yeah. So how does it look like in Zig? We have a Hello World Zig file, which is the goal of this presentation. We want to compile that for ARM, and we use the Zig compiler, and we get an executable. But where does this Zig compiler come from? I mean, it can't jump out of thin air. I mean, it has to go through that same process to be a real executable. So this is where the bootstrapping process of Zig comes into play. So at the current time, we have one code base, which is called Zig Stage 1, and we use a C++ compiler, such as GCC or LLVM, to compile that to an executable. And we call this Zig Stage 1, actually Zig Stage 0, but I'll just abstract over these differences. After that, we have the Zig self-hosted compiler, which is called the Zig Stage 2 compiler. And this is the Zig compiler written in Zig. So just for the explanation of the colors here, I'll use red for C++ code, blue you have seen blue for C code, and green for just executables. So we use this stage 1 compiler to compile the Zig self-hosted compiler, which is written in Zig, to Zig stage 2 executable. And what we want to do after that, the current plan, is to have just one code base, namely the Zig compiler written in Zig, use the Zig compiler to generate C code, and then use a C compiler to get this compiler. But as you can see here, this is not exactly technically the same as bootstrapping, because we have a kind of recursive dependency here. We are using the Zig compiler here, but we only get it down here. So the solution to this, which is also the plan Andrew has, is to separate this, the C code, and into another code base. So we have two code bases. One, the Zig compiler written in Zig, and one, the Zig compiler, which was originally generated from Zig code and is now C code, but maintained on its own. And then we have the normal bootstrapping again. So, and now let's talk about backends. We have our Hello World Zig file, and we want to compile that to an executable. That's okay. But there are different executable formats. If I compile something on my machine, which is an x86-64 machine, and it produces a Hello World executable, which is for the x86-64 instruction set, I cannot run that on, let's say, an ARM CPU or a MIPS CPU or any other kind of CPU which is not x86-64. So here is where the concept of a backend comes into play. So the Zig compiler can also generate from the same Hello World file a executable for the ARM instruction set. And I'll use pink for the color of the ARM instruction set. So this is what you already have seen, just to annotate this in preparation for another concept called cross-compiling. So we can also use the Zig compiler in another architecture and compile, for example, for my architecture on my laptop. So this is called cross-compiling. So I have the Zig compiler, which is running on my CPU, on the Raspberry Pi, for example, which is an ARM CPU, and it's compiling for a target that is not native. Like, it compiles a program that the CPU itself cannot run, but it still can compile this. And this is what we are trying to achieve with the Stage 2 compiler. So before I'll delve a bit into the ARM architecture, I'll talk a bit about the general architecture of computers. Most computers nowadays, if you generalize all the details away, are following the von Neumann architecture. And that means we have a CPU and memory, and this memory contains instructions as well as data. So in detail, this means this memory contains some instructions. Like, what these instructions mean, I will delve into that later. But it contains instructions as well as data, which means I can load, for example, this into a register on my CPU, but I can also load an instruction. It's because it's from the same memory. I can just access it, instructions and data as if they were the same thing. And my CPU contains registers, that is an important part, which are very small amounts of memory, which the CPU can access instantly, well, almost instantly. And we have for example, an arithmetic logic unit, which performs stuff like addition or subtraction or bitwise operations. Yeah, and of course, other stuff in the CPU. CPU is not that simple, but we'll keep it at this. So, and ARM is, in contrast to many other instruction sets, is a RISC. And to understand the concept of RISC, I'll contrast that with a CISC. And CISC stands for Complex Instruction Set Computer. And architectures that are CISC have some properties that the RISC architectures do not have. For example, one of these is that if I compile this very small function without optimizations for x86-64, which is running my laptop, and this is a CISC instruction set. And for example, if I compile this addition, it gets compiled to this. And what we can notice here is that we have one operand, which is a register, but another operand, which is a memory location. This is like a pointer to a location in the current stack. So this means we can, as operands for an arithmetic instruction, we can have as well locations in the memory, which is something which is not possible in a RISC architecture like ARM, for example. Here we can see the add instruction can only access registers. This is the register where the location is saved. This is the first operand. This is the second operand. So this means in R0, we will save the sum of R0 and R1. And you can see here, before we can do that, we need to load all these first. So we need to first, of course, this is compiled without optimization. So these stores and this store are technically dead stores. But the essence is that we need to store them into memory and then load them again. And this, we cannot do this without loading. So in the CISC architecture, we only need to load it once and get the other operand from the memory. But in RISC, we cannot do that. So this is one property from RISC, and RISC also have RISC instruction sets also have many different properties which differentiate them from CISC, but I won't go into detail there. So some few examples of the main instructions we encounter in the ARM instruction set, which are used in every program, basically. We have data processing instructions, which are additions and subtractions and just moving, negation, and all those stuff that operates on registers. Then we have memory instructions, which are like which load and store registers into memory, and we have branching instructions. So without branching instructions, we don't have like real control flow. We cannot do if statements or for loops or while loops. We can only do these with branches, which mean this branch, for example, is a branch with an offset, which means I can jump higher into the code or lower into the code, and this is an indirect jump. So I jump into the address which is specified in a register at the moment. And briefly, I'll show you for example, for the add instruction, the actual representation in the binary file, which is a 32-bit integer here stored in a big Endian way. But the essence is that these operands are saved into the memory locations here. So this is destination register, RD, which is saved here. So this will be 0, 0, 0, 0. This is the first operand, which will be saved here. So 0, 0, 0, 1. And this is the immediate value, which will be stored here. Yeah. So, yeah. Maybe one special thing about ARM, which many other instruction sets do not have. I don't know if any other instruction set does have this feature, but ARM has the ability to conditionally execute every instruction. So every instruction in the ARM instruction set, in the A32 instruction set, has a condition, which means for small if statements or for small code that is conditionally executed, we do not have to have a branch. We can just linearly go through the code and just pick out those instructions which we want to execute and just don't execute those which we don't want. So, for example, this function can be compiled without any conditional branch. This is very important for CPUs that do not have a branch predictor. Some ARM CPUs, in fact, do not have a branch predictor, and this is very useful for them, as this speeds up the code considerably. I look forward to implementing this feature in the Zig self-hosted compiler, but we'll see how that goes. Because at the moment, conditional branches are not yet implemented. Now we'll have a quick live demo on a Raspberry Pi. But before that, I'll show you a bit the code, which actually powers this backend. So this is the codegen.zig file. This is where all the code generation stuff happens. We have stuff which is, we have this generic function struct, which is generic on the current or on the target CPU architecture, because we can cross-compile. And this struct has many different functions, depending on what we want to do. So for example, we can generate a return. We then switch on the architecture. For example, if we want x86 or x86-64, and on ARM, we do this. Like this is, and we also have to do because, this is still a work in progress, this backend. But we also have larger functions such as setreg, which set a register with a value. And you can see here's the ARM switch. And we can set this with, for example, an immediate value or with a register. So we copy one register into another register, or we copy the contents of a memory address into a register and stuff like this. So, and we also have the codegen ARM file, which is ARM specific. This is specific for the ARM instruction set. We have a enum, which can represent all the different condition codes that an instruction has. We have another enum for all the registers that are present in the ARM instruction set. And we have a big tagged union for instructions. Of course, this is not complete yet, but we have the main things here, like data processing, which is a packed struct. So we can directly, once packed structs are 100% complete, we can directly just bitcast this into the 32-bit integer that we are going to write. I can show this. For example, here, when we write a move from one register to another register, we can write this to U32. So this is a integer, and we write that directly to the code. And as you can see here, we have this instruction.move. And we can skip here and look at that. The move instruction just has one register, one operand, because you can also move immediates. And this goes to data processing. And data processing is like kind of the helper function which returns this instruction with the tag type data processing. And then finally, we call the toU32 function, which has this horrible thing here because, as I said, packed structs don't work completely yet. So this is a short overview of the code. For every instruction I currently support, there is a special function, and also for like alias instructions. These are more complicated things, like for the pop and the push instruction, because they aren't real instructions, they're like pseudo instructions, and they change depending on how many arguments there are. And I use the Zig language feature of having like pseudo var args, and like anonymous structs, and depending on the size of the struct, output a different instruction. Yeah, let's have a quick demo of the code on the Raspberry Pi. So this is currently my Raspberry Pi, just to prove. Yeah, it's running a ARM 1176 CPU. It's the Raspberry Pi model B Plus version 1.2. And yeah, I already have, let's look at the code. Yeah. Yeah, let's have a quick look at the code. Yeah, as we have no import support in stage 2 yet, we have to define the start function ourselves. Like, we can't do the normal Zig way of saying import std and then main void, because this requires the standard library, and we can't do that yet. And also the std.debug.warn or get stdio and then print or write doesn't work because we don't have the standard library yet. So what we have to do is we have to write everything ourselves. So I call a print function first. This print function has an assembler instruction, an inline assembler instruction for the literally the syscall into the Linux kernel to print hello world. Of course, once we have the standard library, we don't need this anymore. And the exit function, also like a quick demo of parameters. So parameters actually work. Not fully yet, but simple parameters, like if I just want to pass in one U32, this will work, and I can just set the exit code with this parameter. So yeah, I think I have the executable here. So let's remove this. Yeah, I cross-compiled the Zig binary here. This is, I compiled this from my machine and copied it to my Raspberry Pi, because I thought it may take a bit too long to compile the Zig compiler in C++ on a Raspberry Pi and then also compile the Salesforce compiler. So I just cross-compiled it and copied it into there. Yeah, so this should now be able to compile this hello world Zig file. So this Zig binary is fully self-hosted. It doesn't have LLVM extensions, so it cannot detect which kind of CPU my Raspberry Pi is currently running, because ARM architectures have different versions, and depending on the version, some features work, some features don't. Like, for example, in here we have the move wide instruction, which moves a 16-bit unsigned integer into a register. This is not supported on my Raspberry Pi. So the compiler needs to know if the CPU actually supports this instruction, because if it doesn't, it can't can't possibly run the file. So I'll have to specify the target manually. Yeah, I'll just choose ARM native. And yeah, we have our hello world file.
Joachim, don't forget that your webcam is covering the bottom left part of your screen.
Oh, yeah. Oh, yeah. Then just...
That works. Thank you very much.
I never use the tiling window manager features anyway, so yeah. So, and it works, yay. Yeah, and we can also demo a bit of the incremental compilation here. Update. For example, we can change exit code. I want to exit with 1. Can format. And call update again. Okay, and then I'll open another shell. And call hello. And I'll do this with fish. And you can see the exit code is 1. And we can also change the string. And yeah. No. Pressing the wrong buttons. So, yeah, this incremental compilation feature is really cool. I can just update here, and it just updates. Yeah, this is a short demo of what the Stage 2 compiler is currently already capable of doing on the ARM backend. And of course, this is not nearly the whole Zig language. Loops are not supported yet. Conditional branches are not supported yet. Yeah, imports are not supported yet. So yeah, we have a lot to look forward to in the Zig self-hosted compiler, which I find really, really interesting, and it's really exciting to be a part of that. Yeah. And yeah, that was it. And yeah, I'm looking forward to questions and answers.
Awesome. Thank you very much. The demo was very nice. So it's self-hosted compiler with incremental compilation on a Raspberry Pi.
Yeah, this I can show you the hack I did to compile the because if I compile the Zig self-hosted compiler with Zig build, it doesn't actually register that my CPU and on my Raspberry Pi is an ARM 1167 something, and that's why I modified the build Zig to hard code my CPU here so that it works. But apart from that, yes, I just ran Zig build, copied the binary from the Zig cache, and then yeah, it just works on the Raspberry Pi. Yeah.
Awesome. Wow. Okay, so while people start thinking about questions for you, let me start with the default question. So how and when did you discover Zig?
That's kind of a long story. So in the first semester of university, we had first before even the semester started, we had a so-called Orientierungswoche. So where all new students of the computer science faculty are gathered, and we learn about the university and how stuff works.
So like an open day.
Yeah. I don't know how it's called in English, but yeah.
Okay.
And there was one guy who really inspired me because he said that we should learn as many programming languages as possible, because you kind of if you are stuck with one programming language, your brain starts only thinking like that programming language, and you have more programming languages in your repertoire. You have like more methods of thinking about problems. And I started doing that after the first semester with NIM, which is somewhat similar to Zig. And I even wrote like a pretty non-trivial program in NIM. And if you discover NIM, I think you basically also discover Zig. And yeah, that's when I discovered Zig, and I've been following it ever since. And yeah.
I see. Awesome. Okay, let's see if anybody has questions. So some people were asking before about stage 2. So like if somebody wants to try out incremental compilation, not necessarily on the Raspberry Pi, but like on their normal machine. So we can assume 8664.
Yeah.
What do they have to do?
The stage 2 compiler already has some tests. People can try these test stage 2. Like just like normal Hello World. This is also kind of where I got my inspiration for the Hello World test for ARM, which is here. And this kind of gives you an overview of what stage 2 is already capable of, because these are the things we already test for. Like I think Andrew is the main person working on the x86-64 backend. And yeah, these are the main things that are already supported on that backend. So people can just copy this code, try it out, and then for the incremental compilation, you have to use this watch flag. I think Andrew gives a wonderful intro to how to use the incremental compilation in the coding streams he has done. And that's also where I got my inspiration to do this. So yeah, I think he has multiple coding streams on working on this incremental compilation and working on Zig IR and stuff.
Mm-hmm. You've been working on the code gen part for ARM. Have you taken a look at other parts of the self-hosted compiler, like how it does the parsing and how it produces IR, etc.?
Not so much, but I plan on checking out that because I had a compiler course last semester, and yeah, I also want to see how it's also done like in real compilers.
Mm-hmm.
And yeah, but I haven't looked at that as much as the code gen part.
I see.
Yeah.
Well, sorry, this is just like a bit of curiosity about your university and
Mm-hmm.
but how was the compiler course? Did they like teach you that you have to use Bison and Yak, or were they open to other possibilities?
So we had one compiler course which is mandatory for every student who wants to have the bachelor, which is an introduction to compilers. And I also chose the advanced compiler construction course, which is like not mandatory. And in the first one, we discussed things like basic parsing, ASTs, and basic codegen. And we used Java for that. So we built we built the tokenizers and parsers ourselves, and we didn't use a Yak or Bison. And yeah, I think it was like based on submissions, online submissions, and I don't think like it was really it had much room for creativity.
Mm-hmm.
But in the second course, it was more open, and it was more focused on optimizations. And there you could like experiment with those optimizations yourself in some programming language.
I see. Okay. There is one question. Is there a way to do different ARM code for specific targeted ARM versions? Like, can you do inline ARM for v7 and something else for v6?
This is about the inline ARM embedded in Zig code, right?
Let me see. I think.
Or
Is there a way to do different ARM code? That's a good question. I don't know if this is
like
for.
for the code gen itself, if you have like normal Zig code, I think I can demo this, which is already here. Let's search for v5. Oh. Yeah, for example, here, ARM CPUs older than v5 do not support the BLX instruction, which branches to a register and also at the same time saves our current position to the link register. Like CPUs older than v5 do not support that, and instead we can just do it manually. I plan to do this like more nicer instead of just embedding this into the codegen file. But for inline ARM, if you like want to switch on the ARM architecture and like switch if it has a v5, I think you can do that with conditional compilation. So at comp time, there will be the target is the target is comp time known. So you can have a comp time switch, and then if this target is done is correct, you can output this inline assembly. Otherwise, do this in inline assembly. So that would be a possibility.
Right. Let's see. I think there was a question. Oh, there was a question from way earlier, which mentions the leg VM. I've never heard of it, but so the question was: can ARM executables run on the leg VM? Have you ever heard of what it is?
No, I have not heard of that.
Okay, then I guess JKF SDA will have to give us more information. Otherwise, can't answer. Okay, that was awesome. I have another question though. I've seen that you have on Discord a Rocket logo and URL there. So, what's up with that?
In the first semester, we had a course which is introduction to functional and object-oriented programming languages. So, as for the object-oriented part, we had Java, and for the functional part, we had Racket. And at the beginning, I was so confused by the Racket syntax and the parentheses and stuff, and I almost hated it. And then, as time went by, I began to realize that it's also a useful programming language, and it's also very useful for some stuff. And I then just chose that as a profile picture. Yeah.
I see.
Yeah.
Oh, apparently that was a joke. I'm sorry. I'm way too out of the loop to understand that joke. Okay. There's another question. Unrelated to the ARM backend, but more related to the new ARM MacBooks. How do you create universal binaries for both x86 and ARM inside? Can you?
So first of all, the new ARM MacBooks I think have ARM 64 so ARC 64. But I don't own a MacBook, and I don't know how that works specifically. But you could then use once the ARM 64 backend is complete, you could use that on a Mac. Also, I think the executable format for Macs, the Mach-O or Mac-O, support is also in progress and is in the process of getting merged. And yeah, once that's finished, we should see support for ARM MacBooks coming soon.
That's great. Oh, by the way, there's also Jacob Kubcon in chat who is answering. Who is the one working on
correct,
macro linking, right? So I said that also in the newsletter. I repeated on stream, guys. I really hope like by your powers combined, I will be able to use incremental compilation on the Mac when it comes out.
Yeah.
So let's see the comments. For the record, for the people watching the video, so Jacob replied in chat that as far as he knows, it's fat binaries on macOS which pack both machine code for x86-64 and ARC-64, which is interesting. Because June says it's like a machine code quine. I don't know. Well, I guess the packaging around the machine code itself can be OS dependent in any case, right? So it doesn't have to do strictly necessarily with the architecture. I'm guessing that's data that the OS can inspect and reason about. Anyway, oh yeah, Jacob says, blame me if something doesn't work. I will, well, not blame, but I will open issues and ping you.
Yeah, it's good that we have many architectures we support.
Yeah. Okay, that was awesome. Thank you very much. Is there anything else you want to say before we move to the second half?
At the moment, no, but I'll be happy to come again at Showtime with maybe a different topic. Let's see.
Absolutely. Absolutely. Yeah. I would love to have another talk from you. So thank you very much. And let's move into the break. So as usual, 10-minute break. But don't go away, because after the 10 minutes are gone, there's going to be the second half where I'm going to show you what it means to do an advanced Hello World application. I'm sure you've done like amateurish Hello World applications like everybody, but here we don't do this stuff. Here we go. We want to be extreme programmers. And this has nothing to do with the extreme agile methodology. We are talking about real extreme programming. So see you on the other side. Ooh, almost time. So start tabbing back into Twitch, close YouTube, close Hacker News, close Reddit. Okay. Hello. We're back. Welcome back. Yep. Let's start with the second talk. How did you know I was on YouTube? Because that's what I do when I tab out from Twitch streams. Okay. Let's see. Is everything up? Yep. Is my pointer the right pointer? Yes, it's the right pointer. Okay. So, advanced Hello World and how to become an extreme Zig programmer. So, you've written Hello World before, and maybe you are looking into Zig. You want to get a feeling for the language, and you stumble upon a code sample that shows you how to write Hello World, and you feel kind of weird because wait, why is there no print function? Or more precisely, why is there no print built-in? Like why no print built-in? Okay, in Zig built-ins start with a @ symbol. It's fine, not a big deal, but why is there no print? Every freaking language has a print. What's going on? And some people get turned off by this. I've seen a few comment threads on Reddit where people who clearly have an extensive professional experience debating on tabs versus spaces and where the curly brace should go, new line at the end. Like, these are the details that matter. They also tend to be the ones that are also annoyed by the fact that a language doesn't optimize for writing Hello World. Now, of course, you could say my argument. I mean, I think I understand their point of view. My counter argument would only be, I think there are already enough implementations of Hello World out there. Some fairly efficient, I would say, and they work for most architectures. So I can see that there is always a need for new, better, improved Hello Worlds out there. But come on. So why is this not a thing in Zig? Why this is no, doesn't work. This does work. This is yes. But as you can see, we are importing print from std debug. Why are we getting print from a debug namespace to print? That's also maybe interesting for people that come to the language. Well, I think that the answer for this can be found in the fact that Zig markets itself as a way of writing robust, optimal, reusable code, and I think it kinda ties into that. So Hello World, even though it's meant to be a simple application, in the end, it's not really that simple when you start thinking about the details. So now let's use Hello World as an example, as the starting point for thinking about what it means to print to the terminal and some of the details that can be that we have to think about, that we should think about. So what's your use case? Are you trying to print to standard error or to standard output? And I'm assuming people watching these know the difference. If not, long story short, normally programs have two output streams that they can write to. Standard output is meant to be the actual main output of the application. Standard error is just for, as the name implies, communicating errors. And it's nice to have this separation because sometimes this allows programs to pipe output from one program to another, while at the same time printing useful diagnostic information to the user without messing up the output that the other program downstream is supposed to interpret. In Zig, how do you choose where to print stuff? Well, there is in std.io, you can find two nice functions, get stdout, get stdr, and these two functions give you a file struct, because these are represented as normal files that are open in the program. And then from there, you can do from the file struct, you can do .writer to get the writer interface that allows you, as the name implies, to use that as a generic way of writing to a stream. And from your writer, then you can do print, which is nice. So this is one question that you should think about. Where do you want to print? Another question could be, what if printing fails? What if I have an application where it's extremely important that the print succeeds? Otherwise, we should report the error somehow, maybe even crash. While other applications, maybe you don't care if the print fails, and actually crashing because of a print failure is undesirable. So these are also other choices that you have to make, and there is no one right choice for it. It depends on your use case. So here, this is another example. Here we are doing the standard out writer, blah, blah, blah. But here we are catching the error. I'm not inspecting the error. If you inspect the error, you can also get more information about what's going on. But here, just to simplify stuff, we catch the error, and in this example, I decided that we want to return a specific error code if our print fails. And as you can see, also this main function is slightly different than usual. This one is returning a U8, because normally we return either void or error void, like exclamation point void. But if you return U8, this allows you to specify your final status code for your application. So that also, maybe, depending on your use case, can be useful. Or maybe you could have another strategy. Maybe returning error codes, it's not important for you, but you want to react to a print that isn't happening successfully. Another dimension is buffering. Do you want buffering, or do you not need buffering? And buffering can be very important for performance. If your application has to read and write a bunch of stuff, you want buffering somewhere. Otherwise, everything will be much slower for basically no good reason. So this is how you add buffering to a writer. So first of all, as usual, you grab the standard out writer, and then you feed your standard out writer to the buffered writer function. This function automatically adds a buffer of 4 kilobytes, but if you look at where this function is defined, right above, there's another generic function that allows you to customize how much buffering you want. The reason why this is there is no parameter here, I think this is just a convenience function, and because 4 kilobytes tends to be okay, I guess, for most use cases. But it's also because the other function will generate a type, because the buffer is embedded in the frame. Like, so this, maybe somebody that doesn't know much about Zig might have this question, like, this buffer is not a dynamic buffer that gets allocated. Like, if this were to allocate dynamic memory, it would ask you for an allocator. So this is just buffering inside the type itself, inside the struct itself. So it's in the frame. So after that, you simply, from buffer, you can get, again, the writer interface and use that to write. But then you should consider flush. You also have to take care of flushing the buffer from time to time, or like your last print, you need to, after you know that your print needs to be, let's say, committed, you need to make sure you flush the buffer. So this is another important dimension. Another one, do you want locking? Are you going to have multiple threads going to write at the same time on the same stream? That can be a problem. So let me show you. This is a slightly more complicated example. So let me show you the printing function. But here I'll show you in the next slide why. But this function wants a lock and an ID. The ID is going to be used to basically represent a thread ID. And the lock is what we are talking about, right? Locking and doing mutually exclusive access to a resource, which in this case, it's the standard out stream. The reason why I'm not just passing these two arguments normally, but I'm basically bundling them inside the struct, it's because we're going to see in the next slide. That's how the interface for launching a function in a new thread works. So what do we do in the body? We grab the lock, we defer its release. So this statement here, defer, makes this happen at the end when we are returning from the scope. And we grab the ID, and then we just do basically 3 prints, standard out, no buffering, just grabbing out standard out and writing to it 3 times, the same message. Now, if you do this, and let me show you also the other half of the code. So now this is our main function. Our main function is, well, creating the lock, making space for 3 threads, and spawning them, and then waiting for them, synchronizing to them. And here's also the argst struct that we defined before, which gets passed to do hello. You try it, and that's the output. 3 threads. For some reason, when I did this run, the first thread ran immediately. The second thread, somehow, I don't know, the OS didn't like it, so they said, well, you know what, I prefer to launch the third thread first, and then we'll schedule, well, I prefer to schedule the second one, the third one, and then we'll do the second one last. Now, what's the problem here, though? Well, this is nice, but what happens if we comment the lock lines? How does not locking interact with multi-threading and trying to print on the same stream? It produces something like this. So think, this is, I didn't make this up. This is actually the result of a run that I did. So you look at this. Is this understandable? Do you understand what's going on? I don't know. Maybe some people are fine. Like you look at this, I don't know. This is perfectly understandable. Everything is garbled up. But yeah, so this is a big problem. Like this is not something that you can use to understand anything. And also, what's interesting about this is that this is not just messing up where the new line is. This is messing up everywhere. Like everything is messed up. Like, the T colon was never broken, but man, what a mess. So we just saw a bunch of different things that you should think about when you're trying to print. And if you have at print, maybe you don't think about them as much as you should. So this is why print is inside debug, because it's one choice, like it's one set of choices made for you by this function, which is reasonably good for debug purposes. But when you are writing a production application where, depending on how important printing is, you need to be able to make those decisions independently, one by one, and make the right one for your case. So now I'm going to show you what's inside print. But for the people that don't know, I think it might be interesting, if you want to write in chat, what do you think is debug print giving you? Is it giving you buffering or not? Is it giving you locking or not? Is it gonna give you error handling or not? Is it gonna print to standard out or to standard error? So if you don't know, maybe try to write your prediction in chat. I would like to read a couple before showing the code. Okay, so John says buffering, locking, and standard out. That's a reasonable choice. That would be a reasonable choice. Proti says straight write to standard error with catch return on error. Standard out, no buffering, no error catching from a root dev. Nice. I mean, and every set of choices that each of you is saying, they're all reasonable, right? They would be okay. So it's interesting that a print function that is there for your convenience is making one choice for you, and I think we have all seen way too many programs where none of this is being like customized by the programmer. So let me show you what it actually does. Oh. That's it. So let's go line from line to line. It does have locking. So if you use debug print in a multi-threaded context, you will get reasonable output. But if you are issuing multiple prints, then those, like if you print this and then print that, those two prints, you don't know if they will happen together. So this is basically avoiding the worst case, like what I showed you before, the keys garbled together with the numbers. But this is not a complete solution, right? If you want to have a better understanding of what's happening in a multi-threaded context, then it's grabbing the standard error writer, so it prints to standard error, and if there's an error, it just returns. So in fact, print, you don't have to try print to try debug print. You can just launch it. So I think that's interesting, and I think it's good to know what your possibilities are and why Zig does. Another reason, which actually might be probably even a bigger reason why print is not a built-in, is because languages like C, apparently, to implement format strings, right? So you want to print and substitute certain tokens with arguments that get passed in by the user. Apparently, in C and other languages, you need to implement this stuff in the compiler. It cannot be a user space function. But actually, format strings in Zig, like this whole FMT machinery that is able to, let me go back to where an example is, like the whole machinery that allows you to say, substitute this with the argument that you're giving me. This is actually all implemented in user space. It's in the standard library, and you can implement your own formatting stuff. With C, not so much. So, long story short, Hello World is not that simple, but it's not that hard either. You just have to know what your options are and make your right decision. And now I think this will give you I don't know, after this, after thinking through all of this, I started being a bit more sophisticated about my Hello Worlds. Now, I don't know, not every Hello World is fine anymore. I look at a Hello World application, one-liner, nice, but I start thinking, is it buffering? Is it locking? I don't know. So, long story short, extreme Z programmers actually think of the details. That's pretty much the whole point. Although I have to admit, it's unfortunate that extreme has been, it's a term that has been overloaded so much with agile stuff. So this was, I guess, the main part of the talk. Let me show you one last thing and also one quick demo for people that have gone past the using debug.print, so that are used doing that. Let's talk about std.log very, very briefly. Freund, I think, contributed the whole implementation, so I think people should ask him to do a full talk on why he made the choices that he made, why things work that way, etc., etc. But know that there is a logging system in the standard library that's useful to use. Once you move away from debug.print, so once you stop having prints that are there for really debug reasons, as the name implies, take a look at this. It's a standardized interface for logging. So once you start printing useful stuff that you want to be printed, like when your application runs in production, let's say, for real. It supports scoping and error levels. So error levels, you know those, right? Info, warn, error, critical. There is a good list of error levels that you can use in std.log. Also scoping, it's interesting because it allows you to basically create a scoped logger for your library. So if you're writing a library, you can just at the beginning, at the top level, declare your scoped logger, and then you can give it just an enum. It's very nice. You just specify an enum that is basically the name of your library, and then after that, every log line that you print from using that logger will be prepended with the scope, so with your library name, which is super nice because it allows you very quickly to make it clear that a log line is coming from a specific library instead of other places, and making everything more confused than it should be. Final thing, you can also provide a custom implementation in your root file. So there is a default implementation in the standard library, which I won't show the source code, but if you look at it, it looks very similar to debug print. I don't remember 100% actually, now that I think about it. But I mean, now you've seen all the important things. I'm sure that if you go take a look in the code, it's gonna take a half a second for you to immediately recognize what set of options it's providing you. And you can go read in, as I said, you can go read in the default implementation, but more importantly, go read what's inside this file, because there's a bunch of comments that tell you also how to use it and tell you all the enum options and etc, etc. So there's a bunch of like useful documentation in there. Don't be afraid to read the standard library of Zig. Like I know that if you come from other languages, like I don't know, I'm thinking about my own experience with Java, for example. You don't really want to go read too much into other people's code. I didn't want to read my own Java code, to be honest. But with Zig, this is not unique to Zig, but with Zig, I assure you, especially the standard library, you can learn a lot. Everything is very easy to understand, very clear, well documented. And especially this part here, which is, it has a very, very big and complete explanation on how to use it and how to customize it. So I said earlier that you can provide your custom implementation. So let me show you a demo of that. Let me show you one thing that you can do. So let me see if I can handle properly with OBS. Okay, so now I am showing you my development computer. There's Twitch chat. Say hello to YouTube since we are recording. And it's not just Twitch chat, so please somebody write something so we make sure that it works. And also down here I have the Showtime Discord server. Oh yeah, there we go, there's people. Oh, and there's also King writing true in the Discord server. So this is working. Let me show you. I prepared this project called, like the talk, Advanced Hello World. And in there, I have my main file, which is doing a few interesting things. So we have these Discord logger and Twitch logger implementations that are in two subfolders. I'm not going to show you the implementation just yet, but I mean, I think the name is already self-explanatory. We set the log level to warn. We have a couple, well, I have Discord and Twitch. I save them as global variables. I have a setting for Discord and a setting for Twitch. So my channel name and the ID of a channel inside the Showtime Discord, which by the way, I'm going to change because previously I was testing this stuff in a channel dedicated to bots, but now I'm going to copy the ID of the main channel, place it here. And after that, we get into the main function. So the main function has an allocator, which is necessary for the libraries to work. Here we initialize Discord. Here we initialize Twitch. And here we do a standard log warn. And here, down here, there's our implementation of log in our root file. So this stuff is copied verbatim from the original implementation. This is just building a prefix with the level and the scope prefix. And then in here, we are grabbing a log, printing to standard error. And then we are also using Discord and Twitch to send a message. So we are logging also to Twitch and Discord. So let's see, the message is shields at 80%. Let's put it to 60% so that I don't remember if I compiled this or not last time. So let's make this compile. Let me also open everything so that we can see the result. Zig build run. Boom. We have a log line in Discord. We have the log line on Twitch and on the computer. Now, is this a good idea? No, not really. but we can make it even worse. So let's make this even worse. How do you make it even worse? Well, we implemented log, right? But what if we implement also a panic handler in our root file? So this is a panic implementation that does the same thing. Funny thing, this should return no return, and the only way for me to do that and work correctly is to add breakpoint and unreachable. Maybe somebody else knows a better way of doing this. But here's the problem. We need unreachable because unreachable is, as far as I know, the only thing that makes a function return no return. The second problem is that if we just put unreachable here and we do a debug build, so if we do a release fast build, this unreachable will do nothing. And so I have no idea what will, like, we should not hit it, right? Hit it. So we are not supposed to hit it. So without breakpoint. So what I'm saying is, without breakpoint, I need unreachable for the no return value. But in release safe mode, unreachable is nothing, and which means that, I don't know, this function will not produce a ret instruction at the end. I have no idea. Maybe we're gonna start like skateboarding into random code. I don't know. But in release safe and debug mode, it will do something, but the problem is that it will call the panic function, and we are in a panic function. So if I just leave it like this is gonna continue call itself in a loop. So I need to generate an instruction that basically makes the application crash, and that's what breakpoint does. I don't know if there's another way of doing the same thing, but anyway, so we have our panic implementation here, and now instead of warning, we want to panic. So now we panic. Hello from Twitch. Oh, yeah, from Twitch. So now we panic. Let's see. Let me open. Let me put everything up in the foreground as usual. Zig build run. And boom, we have it. Hello from Twitch. We have it in Twitch. We have it. Import message from a panicking Zig application, and the application crashes. Now, let me show you a final thing. So I said that you need breakpoint, right? Let me show you what happens if I remove breakpoint. Oh no. So not a good idea. Anyway, that was terrible. I hope everybody enjoyed it. I just want to say that, well, let me see 1 second that I need to switch OBS back to the presentation. Okay, so you can find it on GitHub. It's on my account at /advancedhelloworld. Thanks to Benjamin and Zakus for helping me. In particular, the Discord code is straight up stolen from the ZigBot 9001 created by Benjamin, and the code for Twitch was also 100% provided by Zakus. So thank you very much. I have to say, to me, this looks like a very reasonable enterprise grade Hello World. I don't know about you, but like, you want to log, there is also redundancy, 2 different services. It's cloud. You can also you can force employees to have notifications enabled, and so yeah, that seems actually pretty amazing to me. I think the only argument that I'm willing, the only criticism that I'm willing to accept is that we are not sending messages on Slack and Teams, and we are not opening Jira issues. But we can actually give it enough time, and we can actually implement that. I mean, I can offer that as a paid feature, by the way, if anybody is interested in the audience. So I guess that was it for me. If there's any question, let me know. Fizzbuzz next. We could do Fizzbuzz with panics. Like you keep anyway. Bad ideas. These are all bad ideas. Oh man. So there's also there's standard process exit. I see. I like my debug unreachable though. But yeah, that makes sense. So Twitter and Facebook already, please. Yeah, maybe. I really think we need Teams. Like this sounds like a perfect fit for a Microsoft shop. Like a Microsoft partner shop. Anyway, let's see. Any comment? Let me scroll past my message spam on chat. This is a game changer for the industry. I agree. Especially the panics. Like you really want. Also, by the way, maybe let me show you some other bad ideas that were in that code. So I think there is no discussion that this is a bad idea. Although, actually, let me be a bit more serious about stuff. For some applications, trying to log to an external system makes sense, and you can actually see people doing that when building network services. You 100% do not want to attempt this in a panic. Without a doubt, you don't want to attempt a connection. By the way, also another reason why these these implementation are awful. Let me show you the Twitch one since it's simpler. This is send simple message is the one that was that was being used in the panic because the FMT plus args interface relies on comtime stuff that breaks when called from a panic. I don't know. It doesn't compile. I think you hit a to do in the compiler. So this is just a simplified interface where the message doesn't support formatting. Like this opens a connection every time you open it and then closes it. So every time, like you try to print 3 messages and it will open and close 3 connections. It allocates every time. So not a good idea to do this stuff in a panic, probably. But attaching in a more robust way an external system to your logging, that's actually something that really can make sense in certain contexts. But not the way I did it. And a couple other problems is here we are just formatting the message in this format here. There is no escaping the JSON, like Discord uses a JSON format. We are not really escaping the JSON text either. So if you put like quotes, you need to triple. You need to add 3 backslashes before them to. Otherwise, everything will break. Same with new lines and other weird stuff. So yep. But anyway. Oh yeah, right. And there's some people that also used to log to Notepad. Man, that is something also just as funky that can be integrated with the logger system. I mean, it's nice. Okay, so let me see if there was any other question in the meantime. I forget. Can you repeat numbered form args? Yes. That's I think the main point of using number format args, so that you can repeat the same one multiple times. Let's switch back to the presentation. So I think there are no other questions. Oh yeah, but there's a comment that I would like to read because that makes total sense. An enterprise hello world sends an at here in general on Slack. I agree 100%. Like you need to integrate it. You know what? You can use scopes. Instead of using the scope to identify your library, you use the scope to identify the group of people that you need to ping, and you can change the default scope, like the main application scope, to be at here for everybody. That's amazing. Okay, let me find my presentation again. There we go. So for the next time, for next showtime, I'm not 100% sure that I want to give this presentation, so I'll reserve the right to change my mind in the meantime. But for now, this is what I'm thinking I'm going to work on for this week. Masterclass in Zig pointer economics, or more precisely, just an overview of the many pointer types that are in Zig, and also some usage patterns that are not immediately obvious to first-time programmers, first-time Zig programmers, or let's say people that never had to think about whether a pointer needs to be const or not. So this should be it for the next time. And I think that with that, we can say this showtime is over. So next showtime is gonna have a talk from me, probably this one, but as I said, not 100% sure yet. And the other talk is gonna be from Iridescent Rose, and it's gonna be an interesting talk about using Zig to make homebrew programs on the PSP. I used to have a PSP. I loved it. I used to play Metal Gear Solid Acid on it. Well, anyway, see you next showtime then. Bye bye.